Okay, so it is very important. This first part is very important to understand what is the difference between 3D and 2D. As you know, 2D means we are considering the figures which are in 2 dimensions. Okay, and here we will see the figures in 3 dimensions. You can see this figure. This is a cuboid in 3 dimensions. Okay, length, breadth, and height. So these types of figures will be considered here. And first of all, we will see what are the coordinate axes. I will explain you from the figure what are coordinate axes. So if you see this figure, okay, and it will, if we draw three mutually perpendicular lines passing through this O point, this is our O point, okay, and if we draw three perpendicular, mutually perpendicular lines, means first line from O we can draw like this. This is first line, and it can be extended backside also. Backside is, it is also there, and another line from this which is perpendicular to this line is this one, correct? And third line which is perpendicular to all these two lines is this one. This is the third line which is perpendicular to both these lines. So these are three mutually perpendicular lines, correct? So this is called x-axis, but this will be extended backside. This is not till here only, but we can extend this line backside also. Yes, like this. If you can see, just imagine this is 3D figure. Hmm. And similarly, this, so that means this is becoming XO X dash. XO X dash. This is called x-axis. Okay. And when you extend this line, extend this line backside. Imagine that you are in a 3D figure, 3D diagram. This is a 3D diagram. So this is called Y dash, and when you extend this one, this is your Z O Z dash. So these three perpendicular lines, generally we used to draw like this. One line, another line is perpendicular like this, and third line is perpendicular like this. So we will you used to write this x dash o x x axis. This you have to take y dash y o and this z o z dash. So these are called axis. So this is called, and O point is called origin. As you know, this is very simple. X O, you can write x o dash x dash o x is called x axis, and y dash o y is called z axis, and z dash o z is called sorry, y axis. Y dash o y is called y axis, and z dash o z is called z axis. So always you have to take x axis like this. You should take y axis like this and z axis like this. Then you can easily understand. Correct? But here maybe you are getting somewhat confusion because this actually, if you see, actually when you see this whole cuboid, it lies here in a, means here A is on x axis, B is on the plane xy plane, hmm, and C is on y axis, and D is on yz plane, and E is on z axis. F is in the first quadrant, that is called X. It is in the first quadrant. I will tell you, it is not called actually quadrant. These are called octants. I'm coming to that point. Try to understand what I want to say. I want to say that if you draw like this, you can uh, understand better. So this is your, no, can make this one rectangle. Now this is x-axis, this is y-axis, and this is z-axis. Okay, so now it is better. Now you can see easily this is lying in the first quadrant, correct? X-axis, sorry, this is not x-axis. This is y-axis, this is x-axis, and this is z-axis. Now you can easily see this cuboid is lying in the first octant. These are called octant. So when, if you see this, there are actually four parts. There are four parts. It is dividing into four parts. You can see this is the two-dimensional two-floor building. So you will see that there are four. If you imagine like a building, you can see there are four rooms. One here, one is backside, then left side, then left side front. Similarly here, so you have eight like this. You have below below this also you will find one room like this. I'm showing with different color. So it will be like this. Below also you will have one room. Okay, something like this. So means it is dividing into eight. Okay, this is front room. Back side you will have another room is in the back side of this one, red one, then left side and front. Similarly here back side. So it is dividing into 8 parts, means 8 octants. So that is why it is not called quadrant. These are called octants. Understood? Octants, correct? So if you see what are the coordinates, okay? So coordinates of a point or coordinate planes. First we see that what are coordinate planes. Now you can see that there is one, this is a plane, this plane, this part, if you see this part, this is suppose that we have taken AB, ABC. ABC is lying on XY plane, correct? So XOY, XOY is a plane. I will show you, this is a plane with XOY. Hmm. This is XOY plane. If we want to show, we can, I'll try to make you understand the plane. This is a plane. Now you can see easily. This is a plane. Okay. I think it is clear now. So XOY, sorry. XOY is a plane. This is a plane. Hmm. So this plane, like you can see the walls of this cuboid. This backside wall A, B, C, D, E, F. So D, this is O. So OCED, OCDE is lying on YZ plane. Similarly, ABCO, if we take this, suppose ABCO, this part, ABCO is lying on XY plane. So there are, how many planes will be there? 6 planes, 6 cuboid. You have the six uh, 6 sides of a cuboid, so there will be 6 planes. Okay, YZ, but there are 6 sides. Okay, mm, X, Y, Y, Z, ZX is a one plane only, because this will be one plane and it will be extended to this part here also. So we are not considering 2 planes. There will be 3 planes only. Huh? In 3D you will find 3 planes. This plane is extended to this part also. Huh? Okay, got it? So this is a one plane. So XY plane. This will be whole XY plane, YZ and ZX. Means three planes. There are 3 planes, X, Y, Y, Z and ZX. So coordinate, they are called coordinate planes. So now there are 3 coordinate planes, coordinate coordinate planes. No, no, we are not in three in yes, yes, you cannot understand if you will take different axes, horizontal and vertical. That's why I'm telling you. When we are using 2D diagram, just 2D. In 2D, we are taking this. This is x-axis. Our horizontal line is x-axis. Vertical is y-axis in 2D. But in 3D, this is x-axis. This will be x-axis, and this will be y-axis, and this will be z-axis. Otherwise, you will confuse, because we have to see the octants. We have to see the signs of the points, signs of coordinates of a space. Understood? We go to the, so coordinate planes. So coordinate planes. So do not take like that. Otherwise, you will get confused in the octants. Okay, got it? Afifa, got it? So now coordinate planes. So there are 3 coordinate planes. Okay. So there are three coordinates planes. You can see now here xy plane. This will be whole xy plane. So xy plane will be x, o, y. X, O, Y is a xy plane. So x, O, y is called x, xy plane. Called xy plane. Xy plane. Okay. And similarly, y, O, z is called yz plane. Yz plane. And z, O, x is called zx or xz. Same thing. Zx plane. Now octants. We have to see the octants. Okay. So you have seen the z dash. Now space means it is dividing into 8 octants. How many octants? 8 octants. Okay. So what are that octants? If you see this x, o, y, and z, this will be the front one. This one x, o, y, and z. This part, front room. You can say that front room is first octant. Then x, o, y dash. Where is y dash? Is left side. Y dash and z. Left room is the do not take left room. You can go the back side. X dash. Back side is the second octant. They are here third octant. Then this will be fourth octant. Similarly, fifth, sixth, seventh, eighth. Are you understanding? First, front, back side. This is first. I cannot show actually in 3D. This is first. Here it is first. Back side. When you extend this line, back side one you will get second. Then left of that one third octant. Then come front. This is, will be fourth octant. Okay. Then you go in the means ground floor. This is the first floor. So in ground floor, this is fifth, and back side of this is the sixth, then left side seventh, and front eighth octant. So there are 8 octants. Okay. So I will show you again 8 octants. Okay. So if you want to, it is very important because we have to see where the point lies. Where the point lies, like in 2D, we can say by checking their sign, we can say that this point lies in first quadrant, second quadrant, third quadrant. Similarly, here we should know the sign in the octants. So I will try to show you again the octants here. This is O X, sorry, X O X dash, Y O Y dash, Z O Z dash. Okay. So our first octant, first octant. Our first octant will be X X O Y Z. Understood? X O Y Z means front. X O Y Z means this part. Here this is up to Z. We are taking here X O Y Z like this. This whole part you can show by 3D diagram. This part, this whole part means front part. Okay, understood? So, or you can show by this part X O Y dash. So X, O, Y and Z means this part, below part, this one full part, and I'm showing this one till here and here. Okay. So the this is the 3D figure which is lying in the first octant. Okay, understood? So this is our first octant. Similarly, if you go backside, so X will become X dash. So X dash O, X dash O, Y, Z, backside. X dash O, length, breadth and height. You can see by length, breadth and height. Length, anything length, breadth and height. The second octant will be second octant will be X dash O, Y, Z. Means back side. Front room, back room. Now go to left side for third octant. The third octant, similarly the third octant will be this length will be same X dash O, Y dash and Z. So are you understanding? X dash O, Y dash Z. This is our third octant. We are moving in the front. This means first floor. Then we come to the ground floor. So now the fourth octant, fourth octant will be X, OX. And now coming to the front side, OX. So XO, we used to write XO and Y dash left side and OZ. So Y dash, so Y dash Z. This is our fourth octant. Okay. Then fifth again come this side, the below O Z dash X Y. Fifth will be X O Z dash Y or X O Y Z dash, same thing, plain, and then you can. So fifth octant will be, yes, fifth octant will be X O Y Z dash. We used to write X Y Z and in between O, origin, fifth octant. Okay. Then go to backside. Then it will be X dash O Y Z, sixth octant, seventh, eighth. Then sign we have to write actually. So sixth, sixth octant, sixth octant means back room. Okay. So sixth octant will be X dash O Y Z dash, below, not above. We are moving below side. This side we are moving like this. Hmm. Okay. So this is our first octant, means fifth, and then sixth will be backside. So when you go backside, so X dash O Y Y and Z dash. X dash O Y and Z dash. Sixth. Similarly, seventh, seventh octant will be this side. Huh? We have backside here. So that will be our X, this side, this side, back side. backside. So x dash, O, y dash, z dash. Correct? X dash because we are backside, then y dash and below. So x dash, O, y dash, z dash. Okay. X dash because backside. Second, fifth, sixth, seventh, eighth. Eighth will be front. Okay. Like one, two, three, four. Fourth was front. Correct. So last octant, sixth, seventh, eighth. Eighth octant will be X, O, X, O, Y dash, and Z dash. Hope you understood. Now we have to see that if there is a point here in the first quadrant, so how you will suppose I am taking another color. So this is a point in the first quadrant here. This is a point in the first quadrant. So how will you find the position of this point? You have to drop the perpendicular on all the axes, on all the, or if you draw with 3D diagram, that will be better to understand. Like this, suppose this is a cuboid and it is lying in the first, it is lying in the first octant. Huh? So when it is in the first octant, okay. So this is x axis, y axis, and z axis. So if you see this point, I'm talking about this point P. Okay, when you drop a perpendicular here, P O P, not take O P. Suppose P A. P A is the length of this point from x y plane. Okay, so and from this, if you see this distance, this the point of this distance from yz plane or from here. Okay, so this is x coordinate, this distance will be x, this will be y, and this will be z, because this distance is on, if you go here, so you will find here on z axis, so its distance from x z plane is y and xy plane is z. Okay, this is xy plane, so distance from xy plane is z. So its coordinates will be x, y, and z. Okay, so in 3D we have three coordinates x, y, and z. Number one. Number two, very important part, that what will be the signs of. Okay, now as you have seen in 2D also, you can say that if if both the coordinates are plus plus, in 2D I'm talking, it lies in the first quadrant. Okay, so here also you can easily find out by seeing the sign of the coordinates, x coordinate, y coordinate, and z coordinate, where it lies. So it is very easy. You can, in the first quadrant, all the three will be, all three will be positive because x, y, and z. Now I'll show you. Dash means minus, x, y, and z both, all the three are positive in first quadrant. Second quadrant, you can see O x dash means negative. So x is negative, y is positive, z is positive. You can see from here x, y, z. Y means positive, y dash means negative, x dash negative. Here x dash, y dash negative means x coordinate negative, y coordinate negative, z coordinate positive. Here x is positive, y is negative, z is positive in the fourth quadrant. In the fifth quadrant, x is positive, y is also positive, z is negative. You can see dash, dash means negative, x dash negative means x coordinate is negative, y positive because y is not having dash, and z is having dash, so negative. So for minus plus minus. Okay. Similarly, here minus x is minus, y is minus, z is also minus. Okay, all minus in seventh or seventh of 10. Okay, in 7th octant, all are negative. Correct? Wait, correct. And in 8th, positive, negative, negative. Okay. So this you have to remember, or you can imagine, or otherwise you can make one table and like first coordinate, first octant, first, second, third, fourth, x coordinate. Like this, you can make the table. For example, x coordinate, y coordinate, and z coordinate. Okay, and in the first octant, just see in the first octant, plus, plus, plus. You will find the table in your textbook also. But there is a mistake. Some there, I think there is one mistake or two mistakes. I don't remember one. I think one mistake is there in the sign. So don't follow that one. You should remember this one, minus, plus, plus. So like this you can make for all the octants. Okay. So our first question is we have to find their location. Means our question number one, that extra question we are taking. Name the octants in which the following point. Name the octants in which the following points lie. So we have given the points 1, 2, 3, first point, second point 4, minus 2, 3, third point 4, minus 2, minus 5, 4, 2, minus 5, minus 4, 2, minus 5, minus 4, 2, 5, minus 3, minus 1, 6, and 2, minus 4, minus 7. Okay. So we have to check first point 1, 2, 3. Okay, all positive. All coordinates are positive. Here we are getting plus, plus, plus. So plus, plus, plus means it lies in the first octant. First octant. Okay. Second is 4, minus 2, and 3. That means x coordinate is positive, y is negative, and z is positive. So this happens in the fourth quadrant, octant, sorry, fourth octant. It happens the fourth octant. Okay. Then we have 4. So like this we can find out where this point lies. 4, minus 2, minus 5. 4, minus 2 means plus, minus, minus. So plus, minus, minus is in plus, minus, minus. You can see previous plus, minus, minus, plus, minus, minus is in 8. Okay. So 8 octant. 8 octant. Then 4, 2, minus 5. 4, 2, minus 5 means plus, plus, minus. So plus, plus, minus. 4, 2, minus 5 is in fifth octant. Okay. Next is the 4, 2, minus 5. 4, 2, minus 5. Minus 4, minus 4, 2, minus 5. Minus 4, 2, minus 5 means minus, plus, minus. Minus, plus, minus means sixth octant. Sixth octant. Okay. then minus 4 to 5 second octant, minus 3, minus 1, 6 third, and 2, minus 4, minus 7 lies in again plus minus minus, plus minus minus 8 octant. So like this we can find out in which the octant in which the point lies. Okay. Now we have seen already, but coordinates of a point on coordinate axis, x-axis, y-axis, and z-axis. So as we have seen already, but again, coordinate, x coordinate, y coordinate, z coordinate that we have seen. The coordinates of a point on coordinate axis, on coordinate axis. X is the point when the point lies on the x-axis, y-axis, and z-axis. So as you have seen, this is x-axis, y-axis, and z-axis. Okay, so x-axis, y-axis, and z-axis. Okay, if P is a point in the space, hmm, then its coordinates will be x, y, and z. X, y, and z. That means when you drop a perpendicular from P on y-axis, perpendicular from P on z-axis, okay, and this length on y-axis will be y, this is y, okay, and this length is z, and on x-axis also, if you drop the perpendicular on x-axis also, suppose this is coming at this point. So A, this is suppose B, and this is C. So OA, this is x coordinate on x-axis. So this point is x, y, z, x-axis, y-axis, and z-axis means x coordinate is the distance from yz plane. Huh? You can say the distance from yz plane. Here we are considering the plane. Okay. But what will be the coordinates of B? B is lying on y-axis, x-axis, C is on z-axis, and A is on x-axis. So x-axis coordinates of a point on x-axis always x distance, and y and z will be 0. The point A will have the coordinates, and on y-axis 0, y, z, and on z-axis 0, 0, z. That means the point on x-axis will have 0 coordinates of y and z. Okay, so any point on x-axis will be of the form x, 0, 0. Any point on the y-axis will be of the form 0, y, 0, and any point on z axis will be axis. Okay, and so I'll write here one more. So any point axis I'm talking about, any point on x axis in 3D will be of the form x coordinate only, y, z will be 0. Similarly, any point on y axis will be 0, y, 0. Similarly, any point on z-axis will be 0, 0 and z. Now any point on xy plane, xy plane on xy plane. Okay. So on xy plane, y coordinate will be 0. Hmm. So any point, this you can write here only. So any point, if a point lies here on this plane, suppose this is xy plane, here it is a point T. So it will have x coordinate, y coordinate, but it is not having the third dimension above. So 0. So on xy plane, the coordinates of a point on xy plane or any point on x xy plane will be of the form will be of the form means it will have the values of x and y but not the value of z, x, y. And similarly, any point on yz plane, yz plane, always use capital letters for x, y, yz, zx planes, is of the form, will be of the form 0, yz. On yz plane, x coordinate will be 0. Similarly, on zx plane, y coordinate will be 0, x, 0, y. Okay, understood? So any point on x-axis, y-axis and z-axis we can find out easily now. Okay. Now we have the questions in which we have to find out whether it lies or L is the foot of the perpendicular drawn from a point. What are the coordinates of the point? Yes. Foot of the perpendicular, when a point, foot of the perpendicular, suppose P is a point. P is a point whose coordinates are 6, 7 and 8. Okay. Now they are asking a foot of perpendicular on x, y plane. What will be the length of foot of perpendicular on which plane? Foot of perpendicular on xy plane. Xy plane. The foot of perpendicular means distance of x-axis is the distance, x coordinate is the distance from yz plane and z coordinate is the distance from xy plane. That means foot of the perpendicular. So that will be z coordinate 8. Correct? Got it? Z is the distance from xy plane. That is the foot of the perpendicular only. So like this, we can find out the location of points. Now we have the distance formula. Next is our, now we have seen that in 3D, we have 8 octants, 3 axes, okay, and 3 planes. Now we have the distance formula that we have done. That means in 3D, always if any point, suppose P is any point, then its coordinates will be x1, y1, z1. We can have any x1, y1 and z1. So 3 dimensions, so 3 coordinates will be there. And Q is another point whose coordinates are x2, y2, z2. So you have a very small portion of 3D in this year. I think that is the most of the form are extended from class 10th. Like here, distance formula that you studied distance formula in 2D, that is here only extended for z coordinate. The formula is same. So distance between 2 points. Okay, so how to find the distance between 2 points? In 2D, we have seen x2 minus x1 whole square root under root x2 minus x1 whole square plus y2 minus y1 whole square. So here the distance PQ will be z coordinate will also be included here. So x2 minus x1. So most of the formulas you have to add the z coordinate. So x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Z2 minus Z1 whole square. So this is the first formula. Now we have the question. Find the distance between the 2 points. For example, question, very simple type of question we are taking. Find the distance between, find the distance, find the distance between the points A. A point whose coordinates are 2, 3, 1 and B coordinate whose coordinates are 1, minus 2 and 0. 1, minus 2 and 0. So you know that this is what x1, this is x1, this is y1, this is z1. This you will take x2, y2, z2, x2, y2 and z2 and substitute in this formula. Therefore, the required distance AB will be equal to under root x2 minus x1. x2 is 1, 1 minus 2 whole square plus y2 minus y1, that means minus 2 minus 3 whole square plus 0 minus 1 whole square. So 1 minus 2 means minus 1 whole square is 1. Minus 3 minus 2 minus 5, square of 5 is 25, square of 1 is 1. So under root 27. Under root 27. So 9 3s are 27. So 3 root 3 units. So there is a vast application of the distance formula that we have seen in class 10th also. Find that this is a given figure is a rectangle, triangle, isosceles triangle, right angle triangle. So there was 3D, the 2D figure that was. Now we have the questions on 3D figures. Okay. So application is too much. Here also we can have the 2D figures also we can prove in 3 dimensions. Because if it is a 3 dimension, it will make 2D also. If 3 points are in 3D, you will join 3 points, you will get triangle. Okay, in the space 3 points, any 3 point in the space. In the space, you have 3 points. One point is here, one point is somewhere, anywhere. And here, if you join these 3 points, what will you get? The figure will be a triangle. So here also we can consider the 2D figures triangle. Okay. Triangle, rectangle, parallelogram, all quadrilaterals. So now we have the application of this distance formula and some questions on this distance formula that we will do in the next class. Inshallah.